Hello dear students, I am Dr. Ravi Kalsai from Nagpur College of Pharmacy, Vanadumuri, Jingna Road, Nagpur. Let us look at the structure of the benzene. As we know, the benzene ring we are using in our laboratory in pharmaceutical industry. The benzene has been used to synthesize the various pharmaceutical drugs. Apart from that, the benzene has been used to synthesize the various polymers like polystyrene, nylon 66, nylon and the nylon. So it is a very important organic compound. We know the benzene is aromatic and it has aromatic character, or it shows the aromatic character. But there are the various evidences that has been given, or we have to learn so that we can know how the structure of the benzene has been postulated by the scientists. Let us look at here. You can see the structure of the benzene on the above left corner, but there are the 5 different structure that has been given by the various scientists and the chemists. Let us look at all those, the structure and the evidences. This is the benzene ring system we know, but it as a molecule of very special kind. We can also term it as a aromatic hydrocarbon because it has a carbon and a hydrogen. The molecular formula is C6H6. In the structure of benzene, it has been known since 1825. In 1825, Michael Faraday, who first isolated the benzene. After that, in 1833, it has been produced from the benzoic acid and a lime by Elard Michaulish. Charles Mansfield in 1845 isolated it from the coal tar. But till 1931, actually, the no satisfactory structure has been revealed. There were the various scientists like Claus in 1867, the German chemist who stated the structure of the benzene. Look at the structure of the benzene at 1867. This is another structure given by the Devo in 1867, who was the Scottish chemist. Another one given in 1869, a German chemist Lidenberg. Look at this structure. In 1887, the British chemist Armstrong gives the structure of the benzene. In Thiles in 1887, the German chemist who suggests the structure of the benzene like this is more close to the structure what we are expecting in that day. But now the structure of the benzene is like this, that are globally accepted by all of us, that has been given by the Kekule in 1865, the German chemist, and he virtually suggests and he gives the exact idea and put the various evidences regarding the structure of the benzene. Let us look at the various evidences he postulated at that time to derive the structure of the benzene. What are those? He suggests that the molecular formula is C6H6. That is correct. It yields only one monosubstituted product. We know today it yields 3 isomeric disubstitution product. It undergoes the substitution reaction rather than the addition reaction. We know it today. The heat of hydrogenation and combustion are lower than the expected. Dear students, now go to your references, search out the books and the internet, find it out the definition of heat of hydrogenation and combustion. That is actually very important. In the benzene ring system, all carbon-carbon bonds are equal and are intermediate in the length between single and the double bond. Now let us look at the evidences in detail. It has a molecular formula C6H6. It has been given by the empirical formula gives that it is C6H6. There are 6 carbon, 6 hydrogen. But how these are arranged? Like this, like this, like this, or like this. So that is actually the strategy how to arrange all these carbon, 6 carbon and the 6 hydrogen. This one is the Kekulé formula, while another one is the Derivation formula. Let us look at the another evidence. It yields only one monosubstituted product. Look at these reactions, the chlorination and the bromination. You are getting the one chloro or one bromo benzene. That is the only one monosubstituted product. While doing the nitration using HNO3H2SO4, you are getting the one nitro benzene. Another evidence, it yields 3 isomeric disubstituted product. If you are doing the bromination, you are getting 1,2-dibromobenzene or 1,3-dibromobenzene and 1,4-dibromobenzene. Let us look at the various structures of these. Here 1,2-dibromobenzene, how that can be written like this. There are the 2 isomeric form of 1,2-dibromobenzene, while the 1,3-dibromobenzene has also a 2 isomeric form. But 1,4-dibromobenzene has its own structure. Look at this structure, observe this. Here the 1,2-dibromobenzene differ only in the position of the benzene, position of the bromine on the benzene, but Kekulé visualize it in a very different way. He find it out as it is a dynamic thing. He visualized that there will be the resonance structure in this 1,2-dibromobenzene. Let us look at the structure of 1,2-dibromobenzene. Here you can find it out, or you can observe the bond inside the ring system has been arranged differently in both the structure. Let us look at the next evidence that it undergoes the substitution reaction rather than the addition reaction. We have to compare with that of the cyclohexane. When you treat both with the KMnO4, the cyclohexane will rapidly oxidize. Treating with the bromine and carbon tetrachloride, the rapid addition reaction occurs. Treating with the hydrogen iodide, rapid addition occurs. But there is no reactions given by the benzene for this KMnO4, bromine, carbon tetrachloride and hydrogen iodide. But when you go for the hydrogenation, in cyclohexane there is a rapid hydrogenation at 25 degrees Celsius and the 20 pounds per inch square pressure. But with the benzene, it has a slow hydrogenation. You need 100 to 200 degrees Celsius and around 1500 pounds per inch square pressure. So this proves that it undergoes the substitution reaction rather than the addition reaction. We have to compare with that of the cyclohexane, which is aliphatic, while the benzene is aromatic ring system. So there is a difference between these structures. Let us look at the set of reactions, the substitution reaction. The first is the nitration, HNO3H2SO4, you will get the 1-nitrobenzene, while the sulfonation you will get the benzene sulfonic acid. Another set of reaction, that is the halogenation, chlorination or bromination, you are getting with respect to substituted benzene ring system, 1-chloro or 1-bromo benzene. This is another set of reaction of Friedel-Crafts alkylation and Friedel-Crafts acylation. You are getting the respective product. In Friedel-Crafts alkylation, treated with RCl and AlCl3, you will get that respective product, while in the Friedel-Crafts acylation, you have to use the RCOCl or AlCl3, you will get the respective ketone. All are the substitution reaction. This proves the substitution reaction, it undergoes the substitution reaction rather than the addition reaction. Here, let us look at the heat of hydrogenation in the benzene ring system. It is comparatively lower when you compare with the cyclohexane. In the cyclohexane, let us look at the structure. It is 28.6 kilocalorie, only the one bond in the ring system. While in the cyclohexadiene, it is exactly double, the 55.4 kilocalories. You can see the two bond in the ring system. And now the benzene, the cyclohexatriene, it is 85.8, but that should be a triple than that of the cyclohexene, but it is 49.8 kilocalorie, quite 36 kilocalorie less energy. This proves that the benzene is different than the cyclohexane, while cyclohexene and cyclohexadiene are also the different from the benzyl ring system. The benzyl ring system or the cyclohexatriene is typically a different kind of organic molecule. So that is the heat of hydrogenation. Moving further, addition of the alkene, or if when you do the addition reaction, you will get the saturated compound. But the hydrogenation of cyclohexatriene gives the cyclohexadiene and the cyclohexane with comparatively less energy. Next, evidence is all carbon-carbon bonds are equal. Here in the benzene, X-ray diffraction shows that the bond length is 1.39 angstrom. You can compare with that of the ethane, propylene and 1,3-butadiene. So naturally, this is quite standard evidence regarding the arrangement of C6H6. So all these evidences prove the structure of benzene. We will meet in the next video with the reactions of the benzyl ring system. Thank you.